our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry class, and that is your class is your for class 11. This is your class is 13th, and we had done your 12th class of the session in the last classes. We had done your unit 8, which is your redox reaction of part 2 chemistry for class 11, and unit 9, which we even though had started, that the name of the unit is your hydrogen. So unit 9 is your hydrogen, where we had discussed about the physical properties of H2 and G2 in the last class, the structures of matter, structures of hair, eyes, structures of water as well. And we even though had discussed about we have to start discussing about the chemical properties of water. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel. Please like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So we go for the chemical properties of water. So chemical properties of water, where water reacts with a large number of substances. Some of the important reactions that are given here. So first we'll discuss about the amphoteric nature. The first we discuss about amphoteric nature. In amphoteric nature here, it has the ability to act as an acid as well as a base. That is, it behaves as an amphoteric substance. In the Bronsted sense, it acts as an acid with NH3 and the base with H2S. So that is what we have to go for it. So I just write it down for the amphoteric nature here. Here we go. So it has the ability to act as an acid as well as a base. That is, it behaves as an amphoteric substance as an amphoteric substance in the Bronsted sense. It acts as an acid with NH3 and a base with H2S. So we to go for it. This is into, that is your donor acid. H plus donor is your called acid. That is H2O liquid plus NH3 aqueous, which will be OH minus aqueous plus NH4 plus aqueous. Then other word we have H2O liquid. This is donor, this is acceptor. H2S equals. So for the same, it is being H3O plus aqueous plus HS minus aqueous. So for that, the autoprotolysis self-ionizations of water that takes place, that will be H2O liquid plus H2O liquid, it will give H3O plus aqueous plus OH minus aqueous, acid 1, which is acid. This is base 2, that is base. This is acid 2, conjugate acid. So here base 1, which is conjugate base. The second we talk about for, that is being the redox reaction involving water. Involving water. So for that, water can be easily reduced to dihydrogen by highly electropositive metal. So that we have here 2H2O liquid plus 2Na solid, it will give 2NaOH, which is in aqueous, plus H2 in the form of gas. So thus it is a great source of dihydrogen, and water is oxidized to O2 during the photosynthesis, that is 6CO2 gas plus 12H2O liquid will give C6H12O6 aqueous plus 6H2O liquid plus 6O2 gas. With fluorine also it is oxidized to O2, which is 2F2 gas plus 2H2O liquid will give 4H plus aqueous plus 4F minus aqueous plus O2 in the form of gas. Now we talk about the third one, which is being your hydrolysis reaction. In hydrolysis reaction, so for that it will be due to high dielectric constant, it has a very strong hydrating tendency. It dissolves many ionic compounds however certain covalent and some ionic compounds are hydrolyzed in water. So for that it will be P4O10 solid plus 6H2O liquid will give 4H3PO4, which is aqueous. So SiCl4 liquid plus 2H2O liquid, SiO2 solid plus 4HCl, which is aqueous. So for that we have here is N3 minus solid plus 3H2O liquid, and then NH3 gas plus 3OH minus aqueous. So now we talk about for the fourth one, which is your hydrates formation. So in terms of hydrates formation here, where from aqueous solution many salts can be crystallized as a hydrated salt, such as associations of water is of different types. That with is the first we have your coordinated water, so that we have so examples we have, it will be Cr H2O6 3 plus 3Cl minus. So for the second we have as your interstitial water, so for that interstitial water we have an examples here, which has been BaCl2 dot 2H2O. For the third one, which is hydrogen bonded water, in that example we have, which is CuH2O 4 whole 2 plus SO4 2 minus dot H2O in CuSO4 dot 5 H2O. Now we have another question that we talk about it, and that the question we have as follows: how many hydrogen bonded water molecules are associated in CuSO4 dot 5 H2O? So we go for the same. The question is question 4: how many hydrogen bonded water molecules are associated in CuSO4 dot 5 H2O? So here only one water molecule which is outside the brackets, and that the coordination sphere is hydrogen bonded, and the other here for of the water are coordinated. So other four molecules of water are coordinated here. So for the same, we'll just write out the solution here. Only, we'll just write it down. So only one water molecules which is outside the bracket coordination sphere is hydrogen bonded. The outer four molecules of water are coordinated. Now we talk about for another one, which is for hard and soft water. For hard and soft water here rainwater is almost pure and may contain some dissolved gases from the atmosphere or being good solvent, and when it flows on the surface of the earth it dissolves many salts. Presence of calcium and magnesium salts in the form of a hydrogen carbonate, chloride, and your sulfate is the water makes water hard. Hard water does not give the lather and soap. Water free from soluble salts of calciums and magnesium is called soft water. So I just write it on for the hard water and the soft water. Then we'll be doing with it gives the lather with soap easily. So for the soft water, so first we'll discuss about hard water. So presence of calcium and magnesium salts in the form of hydrogen carbonate hydrogen carbonate chloride and sulfate in water makes water hard. Hard water does not give lather with soap. So another we have for soft water free from soluble salts of calcium and magnesium is called soft water. It gives lather with soap easily. Hard water forms scum and precipitate with soap, and soap contains sodium stearate, which is C17 H35COONA that reacts with hard water to precipitate out Ca and magnesium stearate here. So we form it equation. This is 2C17 H35COONA, which is in aqueous, plus M2 plus aqueous will give C17H35COO2M plus 2Na plus aqueous. M is Ca and Mg. So here it is therefore unsuitable for laundry and it is harmful for the boiler as well because of the depositions of salt, and this reduce the efficiency of boiler here. On the same way, where the hardness of water is of two types, which is temporary hardness and a permanent hardness. So it will be the temporary hardness being treated and the permanent hardness being treated. So there were the methods that is being used for it. So we go for first is your for temporary hardness. So the temporary hardness is being so first we talk about for temporary hardness. Temporary hardness is due to the presence of magnesium and calcium hydrogen carbonate, and it can be removed by the first method will be boiling. In terms of boiling, during the boiling, the soluble MgHCO3 whole twice is converted into insoluble MgOH2 and CaHCO3 twice, that is changes as an insoluble CaCO3. It is because of high solubility product of MgOH twice as compared to that of MgCO3, and that is MgOH2 is precipitated, and this precipitated can be removed by filtration. You have to filter it, thus obtained will be soft water, and for that the equation we have here as MgHCO3 whole twice on heating, which will give MgOH twice plus 3CO2 here. On the other we have here CaHCO3 twice is on heating, CaCO3 plus H2O plus CO2 that we have. Now we talk about for the another one, which is for the Clark's method in terms of temporary hardness. To remove the hardness is your Clark's method, so we'll discuss that as well, and that will be in the detail about it. So the Clark's method it is. So the second method we have here is Clark's method. So for the Clark's method it will be in this method the calculated, we just write it down. In this method, calculated amount of lime is added to hard water it precipitate out calcium carbonate and magnesium hydroxide which can be filtered off. That we have CaHCO3 twice plus CaOH twice will 2CaCO3 down plus 2H2O. Now for the another one which we'll be having here is for MgHCO3 twice plus 2 CaOH twice will give 2 CaCO3 down plus MgOH twice down plus 2H2O. So that we have here. And further we'll discuss about the permanent hardness in the next coming class, and hopefully in that class we'll be going to end up with this only, and or after that one class we'll do that. So but before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Other than chemistry part 1 for class 11th that we have to discuss, we had done your physics part 1, which is unit 1 physical world, unit 2 units and measurement, unit 3 is motion in a straight line. We are dealing that. After that we are done with quantitative aptitude. We are dealing with arithmetical ability, in that we are on 17th topic. In terms of we are dealing with the DBMS, we are dealing with the computer based numerical and statistical technique, we are dealing with English vocabulary. In terms of chemistry, where we had done your part 1, where in that we had done your some basics concepts of chemistry, structures of atom, classifications of elements and periodicity in properties, chemical bonding in molecular structure, states of matter, thermodynamics, equilibrium. And in unit 8, which is of part 2, which we had started with redox reaction, where we had completed the classical ideas of the redox reaction, oxidation and reduction reaction, redox reaction in terms of electron transfer reaction, oxidation number, redox reactions and electrode processes. In unit 9, which we have to cover up the hydrogen, where we have to complete the positions of hydrogens in the periodic table, dihydrogen, which is H2, preparations of dihydrogen H2, properties of dihydrogen, hydrides, water, hydroperoxides, heavy water, and now dihydrogen as a fuel we have to discuss. After completing that, we'll discuss about the S block element, the P block element, and as well as 12 unit is organic chemistry, some basics principles and technique. Unit 13 is your hydrocarbons, and unit 14 is your environmental chemistry. So here we gonna end up with. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box.